Hi, it's Jan Beta, and today I'm going to try to build and to test a new diagnostic cartridge for repairing Commodore 64s and 128s, the DesTestMAX cartridge. This is a fairly new test cartridge. Some other retro YouTubers have made videos about this. This was developed by Matthew Desmond, hence the name DesTest, because Desmond. It is very similar to the original Death Test in that it uses the Ultimax mode of the Commodore 64, which overrides many of the chips, the kernel ROM in particular, and some other ROMs. And you don't need the CIAs to work, you don't need much of the system to work to make this run and output something useful for fixing a broken C64. And this cartridge allegedly has some different tests than the other diagnostic cartridges out there, so I am going to add this to my arsenal today, hopefully. We are going to have to build one. These are also on sale from the Future Was 8-bit at the moment, and probably they are going to be available from various other sellers soon. This is openly available on the internet on the website factorofmat.com. You can download the binary file to program an EEPROM and make your own cartridge from various cartridge PCBs, or you can buy a pre-made one from the Future Was 8-bit. I'm going to build one. And full disclosure, I'm not sponsored by the Future Was 8-bit or anything like that. I just like their products very much, and they sent me a little care package some years ago already with some of these PCBs for simple C64 cartridges. You can use different PCBs. There's a plethora of options these days, most of them openly available for download. You can just send them off to your favorite PCB manufacturing house and have them made and then solder up your cartridge. It's not very difficult to build these, nothing really special. You just have to set this up to Ultimax mode and away you go. You should have a standard diagnostic cartridge, death test cartridge configuration. I'm also going to use one of the FutureWas8bit.com's cases, because these are the nice short form factor cases and they should fit these Future Was 8-bit PCBs very well. And they also have a cutout for a reset button, which is very handy. These particular PCBs come with pre-installed resistors and capacitors and also a reset button. So we're just going to have to solder in a socket for our EEPROM, program the EEPROM, and set these jumpers to the Ultimax mode that we need for this cartridge to work. But we're going to go through that step by step as usual. And these cartridges actually have a wrong silk screen. I think they fixed that in the meantime. As I said, this was from a couple of years ago. So if you order some from the Future Was 8-bit now, you should have the correct silk screen print on the PCB itself. Just minor issues with some of the configurations here. That's the plan for today. And then of course we're going to put this into a C64 and see what the new contender for diagnostic cartridges can do. And I think this is just an additional thing for your arsenal. So the other cartridges are not worthless at this point. This is not replacing them. This is just adding more functions for troubleshooting C64s that, as far as I can see, are super useful for some special occasions. Especially RAM testing is very much improved. So yeah, let's build one. Long story short. Let me take a couple of seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs of all kinds. They also do CNC machining, 3D printing, sheet metal fabrication, injection molding, whatever your tinkerer heart needs. And I highly recommend using them for producing PCBs in case you want to make your own DesTestMAX cartridge. So let's build this and test it. So I am going to solder in a 28-pin socket here, and I hope this fits the cartridge shell with the socket and an EEPROM. We're going to see. Might be tight. Not sure if this is going to fit. Maybe we have to solder the EEPROM directly to the board. But yeah, let's see. I want this to be elegant and nice and tidy, so we're going to use the PCB that fits this cartridge shell. There's other cartridge shells available from various sources now. You can 3D print your own and things like that. Yeah, I'm just going to use this for convenience. Yeah, I kind of think this is an ideal solution for this kind of build. Very simple cartridge. Okay, let's see if this fits the shell. Barely. But I think we can make this work. Okay, so I'm going to solder in a socket and then program the EEPROM. Of course, we have to get this out of the socket again without destroying the socket or the EEPROM. And you can use this with a number of different EEPROM types. Ideally, you use an 8K EEPROM. That would be a 27C64, I think. This is a 27C256. So it is a 32K EEPROM. 32K? Yeah, I think so. But you can just use one EEPROM bank of this and it's going to work fine. This supports up to 27C512, so 64K EEPROMs. For our purposes, this is an 8 kilobyte binary that we have to burn on the EEPROM, an 8K EEPROM, of course. Okay, there we are. Socket is in. The next step is going to program the EEPROM, I guess, and then set the jumpers on the PCB. So I set up my laptop here, an ancient Windows machine, and the website cookie banner doesn't disappear, even if I accept. But it still works, I think. This is factorofmat.com, the DesTestMAX sub page here, and you can download the binary here. Legal stuff. Software license agreement. We are agreeing to that. Click to accept. And we have the SL version, which is a version that outputs the diagnostics via a serial adapter. And we have the regular version. This is version 0.1, so it's very early stages development, but it allegedly works pretty well already. So downloaded this, can unzip this. It also comes with a nice manual, 13 pages, so pretty in-depth manual with all use cases, and also the setup for making a cartridge is in there. Highly recommend reading through that if you plan on making your own, or if you want to use one that you bought. Let's download the ROM file, which is the binary, and it's 8K, as I said. To the desktop, maybe. Desktop. And we're going to start up my Mini Pro EEPROM programmer, TL866 first generation, but this should also work with other EEPROM programmers. It's just a standard task, basically. And I have an SGS 2764 EEPROM that I might want to use for this. Let's see. SGS Thomson 2764A. 2764A is what I have here. Very old school EEPROM. I'm not sure if the EEPROM works. If this doesn't work, we're going to use another one. But this is the 8K EEPROM that I found here. Going to select that, open our file, DesTestMAX ROM. This should just be a binary, normal binary. Yep, there we are. Desmond's RAM test thing. So this goes in here like so, with the notch facing here. Let's see. So our EEPROM appears to be blank, which is a good sign. Let's see if we can program it. Nope. Programming stopped. Okay, so this EEPROM maybe isn't the best choice. Plan B, another EEPROM, which is an AMD type EEPROM. Let's see if that works. AMD 27C64. C64 DIP28. Select. We're going to put that in and try that again, shall we? This is a slightly more modern EEPROM. It's still, I think, from the 80s. It's always an adventure. There we are. Okay. Device. Program. Oh, okay. That appears to work. Programming successful. So we now have an EEPROM with our DesTestMAX on it, ideally. Just going to put a little bit of electrical tape over the little window there, so this doesn't get erased. Takes forever for these to be erased by sunlight. These are erasable with UV light, but the amount of UV in regular sunlight is minimal for these, so it takes a long time for the data to vanish. So according to the manual, we have to set these two jumpers here. This one has to be set to game, which is going to be pulled low to enable the max mode or the Ultimax mode. And the silk screen is actually wrong in that game and XROM are in the wrong position. So left is game and right is XROM. So the way we have to set this up is close these two on the left here. And we have to enable ROM H. ROM high, which is the right position here. So these two have to be closed and these two have to be closed. I'm just going to use some wire jumpers. I think I'm not going to bother putting in pin headers here because this is going to be permanently set up to the dev test configuration. And for an 8K EEPROM you don't have to put any of these address line jumpers in. Should be good with closing these two here. Looks pretty tidy. Just going to solder these in and cut off the excess. And then we should be good to go. I'm going to clean this a bit to get rid of the flux that's on there. So at this point, the EEPROM we just made can go in with the notch facing in the direction that the notch on the PCB or the silk screen is facing and the socket. There we go. And this should now be a functional DesTestMAX. Let's try it in a C64, shall we? Yeah, so this is a working C64, not really what this cartridge is aimed at. There we go. Desmond's C64 Max RAM test thing. Looking good so far. So our cartridge appears to work, at least. And it tested our RAM nicely. And it's going through this a couple of times. Yeah, I guess we can put the cartridge together. Let's see if the reset button works. Yep. That worked too. And this is from August 2024, so relatively recent. Yeah, that looks better already. Okay, let's put our little nubbin in here. There we go. Now this goes onto this. And now it closes nicely, of course. There we are. And our reset nubbin works as well. Hey, and it still works in the shell. And it does look really neat sitting in our cartridge port on the C64, which is a bit yellowed. Not the nicest C64 I own, but it works. I'm going to make a little badge for this, just labeling it DesTestMAX. And sticking that on there, I guess. Yeah. So what sets this apart from the other Commodore 64 test cartridges like the DesTest and the Diagnostics cartridge from Commodore that makes it useful as additional test equipment in your arsenal? First of all, this, just like the original DesTest cartridge, can only test 4K of memory, but it does so in a much more reliable manner. So I have an original dead test running here now, which should hopefully start up. Yeah, there we go. That's our original dead test. This is a very, very wonky Commodore 64 board. I just got that out to demonstrate a few things. This is much slower than our DesTestMAX, but it tests a couple of things that the DesTestMAX doesn't test. This is primarily a RAM test, as I mentioned repeatedly. And the dead test tests some other things. There is a sound test for the SID, but usually you realize pretty quickly when the SID is dead. This is very, very useful for initial troubleshooting if you have a black screen system. It does many of the things the dead test does, and in particular it tests RAM, which is one of the most common faults in the Commodore 64. Both the dead test and the DES test work with only 3 major chips and the supporting logic in place. So I'm going to remove the chips that we don't need from this C64 board and see if we can make both of these cartridges run. So the things we need for the test cartridges to output any useful information, basically we need our processor to work, which makes sense because that executes the code, and in our cartridges there is code, of course, that needs to be executed for them to show something on screen. We need the graphics chip, the VIC-2. In these revisions it's here. And we need the PLA. This is the replacement PLA that's pretty wonky, based on an EEPROM. Not the best replacement, but it works for general purposes and should pass most of the tests that we throw at it. We need a bit of RAM, but not very much. So if these RAM chips are broken, our cartridges are still going to work. We don't need the CIA chips, and we don't need any of the ROMs that we have on here. These are the basic ROM, the kernel ROM, and the character ROM. So we need the supporting logic for the PLA, the VIC-2, and for the processor. We can remove the sound chip, we can remove all the other chips, and that's what I'm going to do. And I'm going to try if we can still run our cartridges and if they output something. The dead test should at least report some things, I guess, because it's checking the kernel clocks and things like that, so we should see some output there. The diagnostics won't even start without many of these chips. The diagnostics are more for working machines or halfway working machines to do some more in-depth testing of the ports and things like that. So processor stays in place. SID chip, which is a replacement, as you've probably spotted. It's a Nano Swin SID in this case. We're going to remove the ROMs. This is going to be fun. And this should not start up at all in regular mode because it doesn't have any ROMs. Yeah, that's basically all we need to run this, minus the RAM and some of the logic that's connected to the RAM. That can be broken, and our dead test and DES test are still going to work, at least somewhat. So this is where we are, no trickery here. We removed the SID, we removed all the ROMs, we removed the CIA chips. I'm not sure if the regular dead test works without any CIA chips, but we're going to find out shortly. Let's see. Yep, it started up and it should run the tests it can. And as I said, it's very much slower than the DES test. The clocks here from the CIAs, these are just random because the pins are not populated, and the readings from the CIA time of day clocks are just floating. Usually you would have one time displayed as AM and one time displayed as PM, and that's the clocks from the 2 CIAs. And if those match up, except for the AM and PM, the time of day clocks in the CIAs is good, actually. The dead test has a nice little list of RAM chips, U9 to U24 here. These are the 2 rows of RAM chips in the old Commodore 64 boards with 8 RAM chips. Yeah, this works without any of the chips. And this loops just like the DES test, just loops endlessly and tests the RAM, the 4K it can test. This is not a very in-depth test, but usually this gives you quite a good indication of what's faulty. It has proven really useful especially since you can start this on C64s that otherwise in normal operation only display a black screen or a blank screen. This starts up fine and does some useful tests in case you have the 3 main chips working and the supporting logic for those chips, as I've stated. So let's take a look at what the DesTest does in this minimal configuration. Exact same setup, same C64 with the DesTest cartridge. And yeah, there's a startup test, and now it just loops the RAM test. And you can see the 2 clocks on the bottom here as well when my overlay from my upscaler here disappears. At some point it tests the screen RAM and the color RAM and things like that. So you see some garbled characters on screen. But the RAM test is more in-depth than the RAM test from the DesTest cartridge. And you can see that everything's alright in this machine. You can see the clocks just showing garbage there because there's no CIAs in the machine. But this still runs, which is pretty remarkable. And yeah, that's basically the feature that makes these DesTest Ultimax mode cartridges the most useful for testing C64s, because CIAs break all the time, the SID chips break all the time, the ROMs break all the time, very common faults, all of those. Unfortunately, the VIC-2 and the processors also break, and of course, as you probably know, the PLAs also break all the time. So maybe you don't get an output from one of these cartridges, then one of the main chips, the PLA, the processor, or the VIC-2 is faulty. That could be a hint in that direction, and you can go from there with your troubleshooting, which is helpful in itself. Let's try and use a C64 that actually has some faults, and I'm going to show you what these cartridges do if they encounter a fault. So here's another C64 board that I wrote on, that I repaired it in 2021. And yeah, since then I salvaged several RAM chips from here because I didn't have enough for another repair. I now populated all the slots here for the RAM. I think this originally had all MT RAM, which was all broken. So all 8 RAM chips on this board that were on here originally were broken. And as you can see, this only displays a blank screen currently with RAM chips populated. All the chips are in there except for a SID chip, which this is missing, but that doesn't prevent the C64 from starting up. So let's put our DesTest in here. This is the regular DesTest. Let's see what that does. And that flashes the screen, which indicates a RAM fault. That's the only thing that this does in case something is bad with the RAM that it catches on the initial checks. The DesTest, however, displays some more useful information. Let's see. There we go. That is at least a bit more than what we get from the DesTest. So this has the nicely named border-o-matic bit indicator. These are the data bits, 0 to 7 actually, and they are all red. These are the address lines, 0 to 15, I believe. There's 16 data lines, yeah, makes sense. Displayed here. And red means a fault, so we have complete failure of the data bus in this C64, which would probably indicate some problem with the supporting logic, because I don't believe all my RAM is faulty. I don't think the processor is faulty in some major way, and I also don't think the PLA is faulty in some major way, but that might hint to something like that. Supporting logic for the RAM, probably. Or the RAM is bad. But yeah, you can see a blue border means it fails testing the 0 page, which is a part of memory directly written to by the processor. So something's wrong with the communication with the RAM in this case. Might be the processor even, but I don't believe that. It's very unlikely if you get code to execute that something like that is bad in the processor. in my experience. It can be a lot of things. Let's see if we can simulate some other fault or something. I'm not sure. We're going to play around with this for a bit. It's pretty bad that this is in such a bad state. I thought it would be a bit better at least. Yeah, now it's completely dead. I'm going to have to make another video about this C64, I guess. So I dug out this one, which I dubbed the Thundercats C64, which I repaired ages ago. And I used it for live streaming and things like that. So this is a working C64 and it has all the RAM chips socketed. So we can probably simulate some RAM faults with this, which is what I was after. Let's see. Let's see if this still works at all, because these break all the time, basically. Yay! Okay, at least it gives me a blue screen. Let's see if the DesTestMAX has anything to say about the state of the RAM. No, it's all good, it seems. At least the 0 page and stacks and things like that are still good. Yeah, let me remove 1 or 2 RAM chips and see what this tells me. Just going to get 2 random RAM chips out of this. And now we can probably see some more in-depth information. There we go. That's our bit indicators. The testing the 0 page and testing the stack page failed. There we go. These are our 8 lines here, and these correspond with the RAM chips actually. So let's remove some other RAM chips and see if we can see that. And in case there are bad RAM chips in here, which I probably can simulate as well, you are going to even get a reading of which address is faulty and things like that. But usually you would replace the RAM chip altogether. Yeah, bit 3 and 6. Here is a little table that shows you which bits indicate which RAM chip is bad, and 4 on a 250407, and all the ones that have 8 RAM chips for the C64 board revisions. That's U23. That's the one I put the bad chip in. So these indicate different positions. So bit 0 is U21, bit 1 is U9, bit 2 is U22. But you can clearly see which bit is faulty and which RAM chip that is pointing to. And on the short board revisions and the 250466, which is the last long board revision, these are only 2, of course, because the 8 chips got replaced by 2 larger RAM chips. On the C128, it tests the memory chips that are for the C64, I believe, and it runs in C64 mode on the C128. So it needs a bit more of the system to work. On that machine, it doesn't really test any Commodore 128 specific features, but it's still a good indication in case some of the RAM chips on the C64 side are bad. There's also another thing that's in here. For the short board C64s, the newer revisions 250469, and there's different sub-revisions of those, but they all have the same behavior. They need a CIA2 to run the DES test, and I think the same for the DAT test actually. But the CIA1 can be removed. That's just because some of the logic is handled slightly differently in the newer boards, and there's not all the signals that are needed to start up the system provided without a CAA in position number 2. But other than that, this is really, really useful. I think the thing I wanted to demonstrate doesn't really work because I have such bad RAM chips that they are just completely messed up. But there is another screen where it shows you the addresses of the bits that are bad. Yeah, this points to U23, which is this. And of course, it's going to work the same for the other RAM chips. You can just determine which RAM chip is bad by these border-o-matic stripes, which is a super nice feature. Pretty much the same as the screen flashes on the original DAT test cartridge. But this then goes on, if the RAM is okay or halfway okay in the initial test, it goes on to test the RAM on a more deeper level with several passes and back and forth and things like that. So it's going to make finding slightly wonky RAM a whole lot easier than with the dead test. And this goes a lot deeper and has a nicer interface. I don't know if it's even an interface. A nicer readout. You can't really do anything here. We can push restore. Then it shows you that there's an NMI, a non-maskable interrupt. And it asks you if you hit restore, because that's one of the things that causes an NMI in a C64. Yeah, I did that. This is now, again, a fully working C64 after removing the bad RAM. I think some of it was in here originally even. So I think that's it for today. I've shown you the new, or relatively new, DesTestMAX cartridge. Let me know what you think in the comments, and if you have used one. Matt actually demands that people report back in case they encounter faults or have any suggestions or things like that. It's all in the manual. The address is in the manual. The manual and the page where you can download this and buy this are going to be linked in the video description. I hope this was interesting for you. I think it's a really good cartridge to add to the arsenal. More in-depth RAM testing is always a good feature, and as I said, it's really quick to start up, unlike the dead test, and definitely going to be a useful addition to the test equipment, the C64 specific test equipment that I have here. Probably there's going to be a C64 repair video sometime very soon, because I found a C64 board that doesn't work as expected, even if I already repaired it to some extent. Thank you very much for watching. Thanks for your thumbs and your likes and your subscriptions. Special thanks, as always, to everybody who supports me on Patreon or on the YouTube channel memberships page or on Ko-fi or with single donations. The links to that are in the video description. Hope to see you again on this channel sometime. I'm Jan Beta. Thanks for watching. See you next time. Peace.